Hi guys, so for this question, we're going to be calculating center of gravity for this body. So the first thing you should first of all notice is that the body is symmetric, which means already the x-axis will always lie on this point of symmetry. The only thing we just don't know is at what point will it lie. Will it be up here? Will it be down here? So we're only going to be dealing with finding the center of gravity in the y-axis. We already know where it is in the x-axis. It's somewhere along this line. Formula is going to be y bar equals to v1 y1. This is because this is not a flat shape. This is a solid cone and a solid hemisphere. So it's not just area that you take into consideration. Plus v2 y2 all over the total volume v1 plus v2. So we'll start with the hemisphere. Forgive my drawing. So for the hemisphere, v1 is equals to the volume for hemisphere is actually 2 over 3 pi r cube. If you solve this out, we know that r is 30, so it will be 2 pi over 3, 30 raised to power 3, which will be 18,000 pi millimeter cube, because it's volume. And the centroid has its own formula. Now, the formula for finding the centroid of a hemisphere is 3 over 8 r equals to, so we know the radius is 30, so it should be 30 times 3 over 8, which is 7.5. Next, for the solid cone, the volume for a cone is pi 1 over 3 pi r square h. So it's going to be equals to pi over 3. The radius is going to be, because from here to this point is 30, so it's going to be 30 square and the height is 40. So the answer is going to be 12,000 pi millimeter cube. So now for the centroid, it's simply going to be from its half point down to the line of reference as we solved in the last question. That'll be 40 divided by 2, which gives you from here to here, plus 30 from here to here. So that's going to be equals to 40 mm. When you simply put together all your solvents, you're going to get, now when we simplify this, we're going to get that the y central gravity is equals to 20.5 millimeter. Thank you for listening. Anything you don't understand, please do not hesitate to ask questions. Thank you.